right, here we are on page 2 where our h's and k's are no longer 0. So we're not necessarily centered at the origin. So for this example, y minus 2 squared over 12 minus x plus 3 squared over 16 equals 1. The y comes first, so we know it's going to open up and down. 12 is first, so that controls our a. So a is the square root of 12. B is the square root of 16. Be careful here. This is attached to the y, so that's the second part of the center. And this is attached to the x, so our center is at -3, +2. We're opening up and down, so we graph our center and then go up square root 12, down square root 12. Those will be our vertices. And then go right 4 and left 4, and those are the co-vertices. So those 4 points make our box. We know it's going to open up and down, so if I go to the vertex, I can draw the curve, approaching the asymptotes but not touching. C squared is a squared plus b squared, so c is the square root of 28, and we're opening up and down, so we go to our center and we go up square root 28 and down square root 28, and those are our focus points. For the asymptotes, so y minus 2, x plus 3, notice that matches right here. And then the slope, well, I went up square root 12 and over 4, so there's our slope. One of them goes uphill, one of them goes downhill, so we get the plus or minus. Okay. All right, and this one, well, there was nothing underneath, so I need to technically put it over 1. So I have x plus 4 squared over 1 minus y plus 4 squared over 1/4 equals 1. This is an x minus y, so we know it's going to open left and right. And our center is going to be at -4, -4. The square root of 1 is 1. The square root of 1/4 is 1/2. So left and right, we're going to, from the center, right 1 and left 1. And then from the center, we're going to go up 1/2 and down 1/2. So we get this really tiny little box here. I draw the asymptotes for the box, and our hyperbola opens left and right. So make sure you actually go from the vertices and approach the asymptotes. Okay, so vertices are -4 plus or minus 1 because we went left and right 1. And then the co-vertices, the y value, we went up and down 1/2. So the foci, c squared equals a squared plus b squared, so c equals the square root of 5/4. Since we open left and right, our focus points are also left and right. So from the center, we go left and right, square root 5/4, and draw the focus points. In this case, they're super close to the hyperbola. Okay. All right, so the asymptotes, y plus 4 equals, and then there's x plus 4. Notice those again match the parentheses. Here we went up 1/2 and over 1. So our slope is just 1/2. 1/2 over 1 is 1/2. One of them went uphill, one of them went downhill, so we put a plus or minus in front of our slope because there's technically 2 asymptotes. Alrighty, so E, 9x squared minus 4y squared plus 8y minus 40 equals 0. So we need to put this one into standard form first. So first I group my variables, so I have 9x squared. The 2 y's go together, and the 40 I move over to the other side. So out of the 2 y's, I take out the -4, so that leaves me y squared minus 2y. But now I need to complete the square. So 1/2 of 2 is 1, 1 squared is 1. But if I were to distribute this, I actually added a -4 on the left side, which means I'm going to add a -4 on the right side. So I can now factor this. So I have 9x squared minus 4 times y minus 1 squared, and then 40 minus 4 is 36. Like the ellipse, the hyperbola always has to be set equal to 1, so we're going to divide everything by 36. Because that way 36 divided by 36 is just 1. So when I divide this by 36, it becomes x squared over 4. When I divide this by 36, I get y minus 1 squared over 9, and equals 1. So it's x squared minus y squared, which tells us it's going to open left and right. There is no h, but there is a k, so our center is 0, 1. So I graph the center. The a, square root of 4, is 2. The b, square root of 9, is 3. So I go right 2 and left 2 and up 3 and down 3 and use those points to make my box. I draw the diagonals of the box. Again, the x squared came first, so I know it's going to open left and right. Make sure you actually touch the vertex and approach the asymptotes. Touch the vertex and approach the asymptotes. Focus points, c squared equals a squared plus b squared. So c is the square root of 13. And we went left or right square root of 13. But since we're adding it to 0, that's just the square root of 13. So that gives us our 2 focus points right there. And we get y minus 1 equals, there's nothing there because again, the center for x was at 0. But we went up 3 to the right 2, so our slope is 3 over 2, but again there's an uphill and a downhill, so plus or minus. Alright, our last one you can see looks a little strange, but we're going to start it anyway because it's good practice to do the completing the square part. So again, I look at just the y's, 16y squared, 64y. So I take out the 16, which leaves me with y squared plus 4y. Then I look just at my x's, the minus x squared plus 2x. I take out the negative 1, which leaves me x squared minus 2x. I move my constant to the other side, so equals negative 63. Then I'm going to complete the square. Half of 4 is 2, 2 squared is 4, so I add 4, but I actually added 64. So 16 times 4, so if I add 64 to the left, I have to add, that's a 64 right there, so I add 64 to the right. Then complete the square again. Half of 2 is 1, 1 squared is 1, but if I were to distribute this, I actually added a negative 1. So if I add negative 1 to the left, I have to add negative 1 to the right. And when you add this all up, it equals 0. This factors to x plus 2 squared, or y plus 2 squared, sorry. This factors to x minus 1 squared. Now, we would take this number and divide both sides to get it equal to 1, except it's a 0 and you can't divide by 0. So, unfortunately, this equation does not work and it doesn't actually form a hyperbola. But that is still the process for completing the square, which is good to see. So that finishes up page 2 of graphing hyperbolas.